Hi, this video is on definite integrals. So let's first recall integration can be used to find areas, volumes, central points, and many other useful things, but it is often used to find the area under a curve of a graph of a function. So before we begin with definite integrals, let's go back and remember a few things. This symbol, right, is called the integral, right? It also stands for the sum of our function, right? Our function f of x is called the integrand. The integrand is our function. The d sub x, remember, is going to symbolize or it's going to give us what our change of x is, but also it allows us to see what our variable is. All right? And our variable is technically x. Okay? For a definite integral, it is an integral with lower and upper limits a to b. If x is restricted to lie on the real line, the definite integral is known as a Riemann integral or the sum or Riemann sum. Okay? Now, please note that our integral here has a lower limit of a. This is your lower limit. All right? And our upper limit of b. This is your upper limit. Okay, now we won't get into very much detail about the Riemann sum, but Riemann sum just pretty much says they take the area under the curve and they separate it in different partitions of different rectangles. In this case, we have 1, 2, 3, 4, 5, 6, right? Usually we use between 4 to 8 rectangles to figure out what our sum of our area is under a curve. And we usually use this type of formula here. But for today's purpose, we are going to not do the very in detail part, but we're going to do something very simplistic. Also, I want to talk about that if we're talking about a definite integral, right? A definite integral is between our limits. Remember, this is your lower limit and this is your upper limit, but it's bounded between our a to b. Okay, it's between that interval a to b. And if we talk about our indefinite integral, right? Our indefinite integral has no bounds. You see, there are no bounds on either end, right? It is just simply the space shaded up underneath the graph, and it could continue on. There's not a limit between our numbers, okay? An indefinite integral should always result, right, in a function. It should get some type of particular function. As a definite integral, since we are bounded between some number and we want to get this space, this area or this space, right? Then our ending result should always be some number. Okay? So, definite integrals mean they're bounded between a number, they have limits. And indefinite means that we just have a resulting function. We're not in between two particular upper limits or lower. I'm not in between any two limits. Tongue tied. Okay, so let's do an example. I want to give you something what we call the fundamental theorem of calculus. So the fundamental theorem of calculus says if f of x is continuous on a and b, then the antiderivative of f of x on that integral, right, from a to b, I'm saying a lot, would end up in a result of f of b minus f of a, okay, once we take our integration. So technically, we are still finding our average rate, our rate of change, but it's our rate of change between b and a. So let's say I have x squared, right? And I want to find the limit of x squared between 2 and 4. So, all right, so let's see, we have the integral from 2 to 4 of x squared d sub x. Now again, I am trying to find this area under the curve between 2 and 4. Oopsies. So I want to find this shaded space underneath this graph here. So the first things first is you have to integrate. Again, in order to integrate, it's technically doing the what? Antiderivative. So this would be x squared plus 1 over 2 plus 1, which essentially would give me x cubed over 3 plus c. So our second part is now we want to evaluate it from the limits between 2 and 4. So that means now we would take 4 cubed over 3, right, plus c, minus 2 cubed over 3 plus c. So 4 cubed over 3 will give me 64 cubed plus c, minus a 8 cubed, not 8 cubed, 2 cubed is 8. So 8 over 3 minus c. Now what did I do? Ms. Parker went ahead and distributed the minus sign. Okay, so 64, the c's would cancel out, and 64 minus 8 will give me 56. So 56 over 3 is my area underneath this curve. Okay, no need for decimals. We are just writing it out. Shall we do another one?
Yes.
So we have to we want to integrate or find the area under the curve from 0 to pi over 2 of cosine x dx. So the very first thing we have to do is, again, number one, we must integrate. So in order for us to integrate, the antiderivative of cosine x is just going to simply be sine x. So we have found the integration of sine x, but now we need to evaluate it between the limits of 0 and pi over 2. So this would simply be sine of pi over 2, right, minus the sine of 0. The sine of pi over 2 will equal to 1, and the sine of 0 is 0. So 1 minus 0 will just simply equal to 1. Okay? So, of course, you're not always given something so easy, and you do not always have to draw the graphs. Let's say I have given you, let's find the integration of -2 to 0 of x squared plus x plus 2 d sub x. So first things first, we must integrate. Find that antiderivative. So this should give me x cubed over 3 plus x squared over 2 plus 2x. And we want to integrate between our interval or our limits, -2 to 0. They are bounded between those two numbers. So let's plug in. So this is saying now 0 cubed divided by 3 plus 0 squared divided by 2 plus 2 times 0 minus a -2 cubed over 3 plus a -2 squared over 2 plus 2 times -2. Well, all of this on the left-hand side should come out to be 0. 0 cubed, 0 squared times 0 is 0. Minus negative 2 cubed should give us a negative 8 over 3 plus 4 over 2 minus 4. This should now reduce down to a negative 2. So 0 minus negative 8/3 minus 2, because this should gave us 2, and 2 minus 4 is still a negative 2. But if we have to add this together, combine our numbers together, then we would have to find our least common denominator, which happens to be what? 6. So if we multiply this one by 6, right, then this will give me a negative 12 over 6. And if we multiply this by 2, this should give us a negative 16 over 6, right? And then negative 16 over 6 gives me minus a 12 over 6 gives me a negative 28 over 6 minus 0. These two negatives become positive, so that will give me a positive 28 over 6, and we can reduce 28 over 6 to 14/3. And then that will be our resulting area under the curve for the x squared plus x plus 2d sub x. That is our area underneath that curve. All right, we will do some more intricate examples in a minute, but that's the end of this one. Thanks. Bye-bye.